I think it's 9 o'clock or a few minutes after, so let me get started. If you were at the session on Thursday afternoon, you heard me say a little bit about the Centers project at that point. Let me repeat some of it. About almost 10 years ago now, EAF decided to support some centers for inquiry-based learning with the idea of trying to advance, develop, and promote and disseminate inquiry-based learning, not only on the campuses involved, but more generally across the country by a variety of projects and areas. Some of the impact of those efforts are chronicled in this newsletter if you haven't looked at it. Mostly it's just numbers of students, numbers of postdocs, numbers of instructors, and so forth. But that will give you some idea of the impact that these centers have had over the last 5 years. At each of the legacy meetings since we started, we've been giving a report, kind of an update on what's been happening. This year we're going to try to do it a little differently. We're going to try, as the title indicated, what we have learned about IBL at the centers. And I'm going to call on each of the people from most of the centers to tell us a little bit about perhaps a little bit about what's been going on, but more on the idea of what does that mean for them, what have they learned, any surprises, and so forth and so on. And I'm going to start with Ralph Spazio from the University of Michigan.
I'm one of these old-fashioned people who like the blackboard, and for one reason, because I think these kinds of things are kind of boring. Okay. Or actually, I like it even better if I don't use a blackboard, watch other people, students, use blackboards. Anyhow, here's some news. So we had a new hire this year, Nina White, who's in the room, who we hired as a lecturer, and she'll be working mostly in the math ed program. And I think it's fantastic news for us because I think it's going to bring a lot of continuity to the math ed program that we have. We will still train some postdocs and grad students in using IBL ideas in math ed courses, etc. But I think it's fantastic. So, and if you want to have conversations with Nina, maybe you can just raise your arm. Okay, thanks. Other news. We have some postdocs moving on, 2 of them, and I'm not going to repeat the names. You have 3 new ones, more precisely arrived last year. There's going to be a half of a new one, i.e., we have IBL courses, things we call IBL courses, and we have some courses that have some IBL elements, and so the new postdoc whose name is not there is going to teach one of the courses that have a little bit of an IBL element. So anyhow, I didn't want to put him up there. 2 grad students are moving on. Both of these were trained in the math ed courses. They're assistants to our math ed courses. And you have a new tenure track person coming in who will be teaching one of our IBL courses, namely a topology course. And she's never done it before, but seeing her and knowing her, I think she'll be great at it. Don't tell her that I said so. So anyhow, what's next? Okay, so here are some things for reflection. So what we learned, well, I was thinking about going very philosophical. I didn't have that much to say. So, and then I thought, well, maybe we should just talk about what we actually are doing. So what's our program structure? Well, you see it. So we have IBL courses at the freshman level. And I think that's something very important. That something seems to come up again and again and again. If you catch the students on their way out as seniors, well, maybe that's a little bit late. So it's really great if you can catch them earlier on, in particular if you're a freshman. And so I have some courses there, but we also have math major courses. I'll throw out some names in a moment. Then, as you already know, we have some math ed courses. So many new courses. Here are some names. Some of them have been mentioned before during this meeting, so I'm not going to go over them. Then, let's not forget, we have our IBL calculus program. By IBL, I mean, well, these are not full-scale IBL courses, but we have a lot of IBL elements in them, and we've been running them for, is Mort here? He would be able to tell you, because he was one of the people who introduced them, for 20 plus minus years. They're still running. We're still defending them from any administrators. So, great so far. Hope it lasts. They are in small sections, 32 students. That's pretty good for a state university. So thinking back about it, so in 2004, we thought about, running this IBL Center or competing for one or whatever the story was at the time. And so finally, and I have to tell you, I didn't know anything about IBL at the time, so of course I was a bit skeptical, as you would be if you didn't know anything about something. But somehow my arm got twisted, and I ended up in the position I'm still in, namely trying to lead this program. And so there we were, trying to come up from scratch or using some other people's ideas, in particular Mort's, in building an IBL program. And so it's taken reflection. It's taken time and effort in thinking and failed efforts and whatnot. And I would say, actually, in some sense, the math ed program was the hardest because we went from courses that were completely pure lecture style in the 1990s, which were the same every single year, delivered by the same guy until retired, and then through a period of various people teaching the course in various ways, to then, when we started in 2005, trying to teach them in an IBL way, which led to lots of head scratching and difficulties. And I think finally we had a transformation. And the students coming into these courses had a transformation because, one of the things you have to realize is this is for reflection, right? So here's my reflection. We have these courses, we are new courses, the students think, okay, I'm coming to this course, some guy's going to lecture to me, I'm going to get an A or A minus or whatever they expected to get. And suddenly you have to do some work. Now, of course, that's a difficult thing. But the transformation is you keep at it, and after some time, the students don't remember any more what happened in the past, and they come in with different attitude, maybe are different students too. And so anyhow, I think over time and with all the changes, lots of people, in particular many of our postdocs working really hard, and grad students who are involved in the as course assistants working on these courses really hard. I think we are now in a very good position with the math ed courses, and I'm really glad that Nina is continuing on with it. Nina, I should say, was a grad student in Michigan, and she was a graduate assistant to the course, and this last year she has taught courses for us, and we finally were wise enough to hire her so, as a lecturer to move this forward. So other ideas. We always had group working in classes, in calculus, but always. Look, I have finite memory. I've only been there 23 years, so, more or less from the time I arrived, there was group working classes. So, of course, we are good at group working classes, and that's a thing that comes naturally. And so that's one of the things, that's how we teach IBL courses. So that's one of the things I want to say here is, there are many different ways of doing IBL courses, and that's what worked for us, that's what came natural, and that's what we seem to be reasonably good at. So other ideas we had were using IBL modules. Actually, an idea of the chairman who twisted my arm, Trevor Woolley, to use IBL modules. So what's that? Just take say you have a 4-credit class, meet 4 times a week, take them on a day a week. I usually take Tuesday because it's, then you can do Monday, Wednesday, Friday in the more regular way. And then on Tuesday, you do some material which is related, not the same, and you do it in whatever fashion you want, whether it's, Moore method or whatever else you want to do. So actually, what I've been doing in these courses is, maybe modified Moore method. Here you go, here's some axioms. Go say something about measure spaces and measures and construct Lebesgue measure, and end up doing it essentially on your own. Well, with a little help, of course, as always. Except you're doing group work. Sorry. So it's, I don't know where it stands in all these definitions. Anyhow, so this is something we tried. We tried different things. Different people like different aspects. So, our basic philosophy here is let people try to work out things the way that's comfortable to them. And, you already heard about Nina. You already heard about 2 other people who are moving on as postdocs. So I think one of our things that we've done very well is training new people in IBL and sending them out into the world and hopefully taking their ideas with them. In fact, then I come to these meetings or the joint meetings, I always see people who went through, who benefited and moved on. So I think this is great. Hopefully we'll continue this in a large way. And here's another idea that we haven't discussed much. But I think it's a fantastic idea. And you know, if you think about money, it's great value for the money. Use advanced, really good undergraduates as course assistants. How do we do this? Well, okay, you could say course assistant, that's a fancy name for somebody who grades for homework. Okay, it's also a fancy name for somebody who leads a discussion session. It's a fancy name for somebody who has additional office hours. Why is it important to have additional office hours? Because a lot of the students are a little afraid to come to you as a professor and tell you about all the problems they've had with the homework, with the write-ups, with whatever they're supposed to do. So, and, you know, you pay them whatever. Not as much as me, so it's cheap. And they learn a lot, and it's good for their career. You can go apply to grad school and say, hey, I've been a course assistant, you know, wherever, Michigan, wherever. So I like this idea very much, so that's something for reflection. I'm not going to say anything about assessment, but I wanted to put it on here. Okay, advising. It's another topic that hasn't come up very much. But the question has come up, how do you get students to take these courses? I think it's very important, and the longer I do this, the more I realize that they really need to be involved with the advisors. And that could be for the advisors for the freshmen coming in during orientation, or it could be the advisors you have in your math department who tells people to take this and that in the next course, or you know, all the possibilities. So it's very important. So for example, in Michigan, we have an honors group at LSNA, and we have several professors, me included, who actually go and do some advising over there. So basically talk individually to incoming students, tell them about all our courses, and we try to tell them, you know, figure out what courses we might like, maybe one of our introductory IBL courses, etc. So anyhow, I think it's very, very important. We discussed it yesterday. IBL workshops, I think it's a fabulous idea. It's a great way to spread the word, to spread ideas, to spread techniques, to spread discussion. Hope we can continue this very much. Well, so we've been at it for going to be 10 years, sort of. Well, maybe we can say at this point, this can work. And we have, based on positive assessment results, but also just the reactions you get from students directly or from the instructors. So that's great. We have had a huge transformation of our program. I think I made it clear, especially in math ed, but also in other parts. And I'm going to say one more thing here. You teach an IBL course. Like I do this, you know, I told you about these IBL modules. And then you go back and you teach your lecture style course. Well, you're not. Because suddenly your lecture style course becomes much more interactive. You don't even think about it. Because, you know, the students are much more open to asking you questions during the class, and it's becoming interactive, and you ask them questions. And, you know, I typically do this thing where I ask a question, I actually don't answer. One time I walked out for 5 minutes when they really didn't answer it. Okay. So I think that one of the biggest impacts is actually one we don't try to measure because it would be probably very difficult, namely what's the impact on the culture in teaching in really hardcore IBL classes. I think that's huge impact. You know, I'm supposed to move on? Okay. I also believe it's good for postdocs and grad students for the later job prospects. This is anecdotal. It's great for undergrads. I think it's clear why. And even math researchers, let me say a word about it. You know, I'm a pretty heavy-duty math researcher, so I apply for NSF grants for research, not just for, you know, education. And in my NSF grants, actually, in the reviews, I get to see what they say about, you know, what do they call it usually? The non-research side of the grant. Broader impact. But in both my last reviews, this has come up, you know, and I was involved in IBL, so this kind of, in a positive way. I was surprised, but first of all, it's there, and secondly, it was positive. Well, don't you have to have 30 seconds? Well, okay, I'm being pushed on here. Of course, that's the last thing you have to think about. Thank you.
I'm sorry to sort of indicate hurrying up, but I did want to draw a couple of conclusions from some of the things that Ralph said. One of the purposes of the centers, as you can see, having sort of a systematic effort at a department allows all kinds of interactions and all kinds of broader influences to occur, as opposed to just having one person or maybe two people teaching in a department. And these are some of the things we're looking at here. Okay, so let me now ask Elizabeth and Carla from UC Santa Barbara. Where are you guys at? You can come on up. And I apologize, I did not remember your last names, but anyway.
Okay. I'm Elizabeth Thoren. I'm at UCSB. I'm the lecturer this year. I was a postdoc before, but now they've hired me on as a lecturer to teach the IBL courses. What are we learning? I'm going to talk about our post-calculus sequence, and then Carla's going to talk about what's happening with teacher training. We're learning how to use technology and wikis to support IBL learning. So we're sort of trying to get an asynchronous inquiry-based thing happening outside the classroom to enhance the synchronous inquiry-based learning that's happening inside the classroom. So I personally have learned a whole lot about how to incorporate a wiki into an IBL classroom. Most of it is contained in a paper that I wrote with Brian Katz that should appear in Primus very soon, we hope. Basically we're finding ways to make space for reflection and synthesis that's really going to enhance what the students are doing in the classroom, and I think I'm very excited about all this. I've worked with several graduate students sort of as apprentices in my class, so handing over the class, letting them take days. A couple of my grad students have taken materials that we co-authored we had 2 new courses this year, so we had to write new materials for linear algebra, new materials for differential equations. And one of my graduate students took materials for the linear algebra and then made worksheets that disseminated amongst, the 400 students that are taking regular old linear algebra at UCSB. So they were doing sort of IBL type things in their sections, just because of the sort of trickle-down effect. Let's see. The other thing that's exciting is we did the MAA prep workshop last summer, and it was very successful, and it was a very exciting experience for those of us who were organized and those who participated, and I've been really happy to run into lots of people who participated and hear nice stories about how they're using IBL or how they plan to use IBL in their future classes. And I just read Chuck and Sandra's summary of the feedback that they got from participants immediately following the workshop, and it looked great. It made me feel good to read that, to be part of such a successful thing. So that's all I have to talk about. We're going to be really short.
By the way, you might mention the ongoing email.
Oh, yeah. And that's in large part due to Stan, but we have a pretty serious email list that keeps going. People keep posting what they're doing, how they're doing, what their questions are, and keep getting support from experts because everybody's on this list. I think what we're learning at UCSB is how to train new users and how to incorporate new. Yeah, definitely. Oh, yeah, Ron's asking if we're learning how to foster community, and I would say yeah. Okay. Yeah, but we're definitely building a community. I mean, I'm running into people like crazy here, and it's a lot of fun.
Hi, I'm Carla Abadi, and I work kind of in the K-6 arm of inquiry mathematics, and I came to IBL through as a student in the teacher education program at UCSB, and I took a course from Bill Jacob, and I thought, I had no idea that math could be like this. And so I continued to take courses and more courses, and now finally get to work with Bill and Monica Mendoza, who's not here, in K-6 classrooms in Santa Barbara. We sometimes have people who come up from other parts of Southern California to attend our workshops. But we're really trying to spread IBL in these lower grade classrooms. What's helping us right now is the adoption of the Common Core state standards, particularly the math practice standards. So we are working with teachers to help students write proofs, essentially, in kindergarten, first, and second grade, where they're sharing their thinking, they're able to hold their own strategy in their mind while taking a look at another student's strategy and being able to see the similarities and the differences between the two. It's fascinating work. I love it. I really, really do. Some of the biggest challenges this year have been helping change teacher practice in K-6 classrooms. Teachers, K-6 are often very math-phobic, and they're also very used to being deliverers of information. And IBL, as you know, is not about information delivery. And so, it's been a challenge to get them to appreciate that their own mathematical development and their own understanding will affect the classroom. Maybe not in terms of a one-off worksheet or something like that, but in terms of kind of a greater knowledge base. And what else do I want to say about that? I wanted to give a little example, really, really quickly, of what inquiry looks like in a kindergarten, first grade classroom. We use Context for Learning Mathematics. It's published by Heinemann. Bill Jacob was a big collaborator, along with Kathy Fosno and Martin Dolk. So it's kind of an international effort to do this inquiry-based curriculum, K-6. One of the kindergarten units that we use tells a story about 8 children at a sleepover, and the aunt who's taking care of them that night will go down, and the girls at the sleepover party are on bunk beds, and they figure out all these different ways to trick the aunt by moving from the top bed to the bottom bed. So they start out 4 on the top and 4 on the bottom. The aunt goes down, she leaves, and they switch around. 1 goes down, and so now there are 3 on the top and 5 on the bottom. And the kids all discuss this. Did anyone leave? Is this different? How is it different? Why? And so then the kids, on their own, investigate all the ways that this aunt could be tricked by moving up and down the bunk beds. And so they're really working on compensation at a very early level. And they're developing proofs for figuring out how they know all the different ways that they could trick Aunt Kate. We know that there are 9 ways to trick poor Aunt Kate, but the kids don't know that. And so one student, I was in a classroom the other day, one student said, well, I put 5 kids on the top and 3 on the bottom, and then I figured out another way by flipping them. He's discovering the commutative property of addition, but he's not saying that. He's talking about flipping. So then he shares with the class his flipping strategy for figuring out, well, if 2 are on the top and 6 are on the bottom, he can just flip them. And he has a new way to trick the aunt, which is different than a compensation strategy where all the kids go down or all the kids go up. So I say that and the teachers, it's a new way for teachers to understand their students' thinking and to know where to guide them. But rather than the facts, teaching addition facts is so huge in K2. Teachers, it never occurred to them that there are other ways of looking at this, is what I'm trying to say. So it's exciting. Teachers, we really, really want to create these self-sustaining inquiry teacher leaders so that there are teacher leaders on site who are leading inquiry in the other classrooms so that we can go on and be working with other schools and impacting a larger audience. So that's our big goal for next year, is this teacher leader component. That was a little long, sorry.
No, that's fine. I've decided, rather than waiting until the end for all questions, why don't I ask for questions now from the 2 presentations that we've had already? Who has a question for either Michigan or Santa Barbara? Anybody? Yes.
Well, I had a question for I love these stories of the kids who are practicing a kind of thinking that if they preserve it for the rest of their lives, they're just going to, inevitably learn how to certainly mathematics and all sorts of other things. How effective are you at teaching the teachers to use this method? What have you learned about how to get the teachers to embrace this?
We present it as really listening to the students. So before anything else, because they've been to 1,000,001 trainings about how to conduct themselves and how to deliver information. So the very first thing we tell them is that you're really listening to the kids. And we're constantly asking them, what did you hear the kids say? What did you see the kids doing? And we're analyzing student work so that they come at it from that place. So they understand the people that they're working with, the mathematicians that they're working with. We talk a lot about, does that kind of answer the question?
So I see, so let's see if I can rephrase it, that you're getting them to imagine the work that they're doing when they're teaching as a different job. Instead of the job of presenting mathematical information, you're saying their job is to be aware of what the student is actually thinking.
Right. So we typically do a 2-day lesson study. One day is we will study a unit in depth, and the teachers will work through the mathematics themselves. Teachers have a hard time understanding that, like I said, their mathematical development will impact the students in a positive, maybe not direct way, but and then we observe them in the classroom, and we're constantly asking questions about that, about what they see the students doing. So they're focusing. We're training them to focus outside of their own delivery system and to the people that they're teaching.
Any other questions? Yes.
It's hard. It really varies from teacher to teacher. Teachers who are very fearful or very embarrassed about their own, what they believe their own mathematical aptitudes are very fearful about, what do I ask the kid? I don't know what to ask. I don't know what to look for. So it's a challenge. It takes a good 3 years, I'd say, for a teacher to really become comfortable. Some teachers more quickly, some teachers more slowly, but I'd say 3 years is to ease into inquiry. But we're helped with the Common Core because now everyone is a little more oriented toward this.
I think we give a good warning to all students who enroll in IBL courses that they enroll in an IBL course and what it means. Mm-hmm. So, I mean, for example, when I tell incoming freshmen about these courses, I tell them, this is work, this is different, and I don't want you to be surprised at the end and say, hey, they didn't teach me anything because you didn't, teach many answers and things like this. And I tell them it's a huge amount of writing in these courses. And I think similar in other courses. So actually, over the time, one thing we've done is that the IBL
they need to come in or not. That's the whole point.
Essentially, students cannot sign up themselves. It's sort of, we monitor the enrollment. We try to make sure that it's, not some crazy. One of the difficulties with an IBL class is if you have some geniuses from God knows where, and together with students who don't have the slightest clue, and they're supposed to work together, that's usually a real problem. So we try to, manage the enrollment in a good way. Things like this. On the other hand, our standard courses are also pretty heavy duty.
I wanted to ask a more technical question.
Let me just stop for a second. I'm being reminded that if we want to have it recorded, we need to use the mic.
There you go.
Oh, now I'm recorded, no one else was. I wanted to ask actually a more technical question, I guess, and that is, could you describe the relationship of the center to the mathematics department or to the math ed faculty? Is that a conscious did you set it up in a conscious way? How did it grow? How did it change? And also, whether there are other disciplines involved besides mathematics.
Let me, they can correct it. We still have some other places, to go to, but as far as I know, all of the projects are parts of the mathematics department. Now, and I believe in all cases, there is some relationship, some formal relationship with education. But it's not, in other words, it's not jointly part of the two, but it's centered in math, but in all, especially the parts that involves math education, there's a formal relationship with the college or the department or whatever of education.
I guess what I'm asking, so there was buy-in to start with?
Yes. In other words, it came out of, in other words, the math department. And I think I'm right. In other words, Ralph and I think, by now I think I speak for this. Let me go on to the question.
2-second explanation. We teach the content courses. They teach the, what's it called, the method courses. But we have pretty good understanding.
Let me go on to the next. In other words, we've got somebody here from Harvard. The 5 places that where we've had center projects have been, as you've heard, Michigan, Santa Barbara, Texas, as you might guess, Chicago, and unfortunately the people from Chicago have got a week-long workshop this coming week, so they're all up there busily preparing for this. And then we've also had a project at Harvard, and we've got somebody here to tell us a little bit about what's been going on there and what they've learned.
First of all, I might not be the best person to be presenting what we've learned. I'm relatively new. The best person to talk to would be Robin Gottlieb, but she's running a workshop on training graduate students to teach mathematics this week, which is, I guess, one of the things that we're doing. It's not exactly an IBL workshop, but some of the sessions are focused on IBL. I was there on Wednesday, and it seems to be a really great conference. So in other news, I mean, we're doing a whole bunch of things, but new things we're doing, we have Paul Bamberg and Kate Penner are writing a new Calc 2 course with analysis. It's an IBL course, and they're setting it up in modules to make it adaptable. The goal is to teach it in the summertime, aimed at secondary school teachers, so that they will know the material a little bit deeper than their students do. And there's apparently a lot of demand for this course, because there's a lot of secondary school teachers who say, I've taken Calc 2, I can do all of the material in Calc 2, but I don't really understand what's going on. They don't want to retake this course that they already know, and so they're writing this course as they run it this summer, and the intention is to adapt the modules in the fall to provide a Calc 2 with a little bit of analysis for students who've taken the BC Calc and who might be resistant to taking our regular Calc 2 in the fall, who might not have the deeper skills that they need to move on, but who don't want to take the regular Calc 2 because they feel they've already done it, to have a slightly deeper and more difficult course for them. So that's an exciting new IBL course we're working on, but we haven't really learned anything yet because it's in its second or third week. We've also got some people working on starting a math teacher circle. In terms of what we've learned, what I wanted to talk about are the 2 things that I've been involved in, because they're 2 very similar programs, and we've had different experiences with them. So 2 years ago, we tried to launch an emerging scholars program in conjunction with our Calc 1 and Calc 2. We called it MOS, the Math 1 Scholar Sessions, and we had the kids meeting for 2 hours in the evenings to do IBL type work, advancing what they were doing in their regular Calc 1 classes. And as the semester was going on, it seemed to be working okay. I mean, the kids who were there, they certainly liked it. It was a lot of fun for me to teach. We were having a great time on Tuesday nights. But in the end, we had one problem, which was relatively low attendance. So we had, I think, 16 students enrolled in the program, and on an average Tuesday, we'd have, between maybe 9 and 12 students show up. And then they didn't have significantly better test scores than a comparable group of students who hadn't been in the program. So we were having fun with math on Tuesday nights, but it didn't really seem to accomplish very much other than maybe something about math attitudes. So one of the things we're trying to figure out, so maybe it's not what we've learned, but what we'd like to learn, is why did that happen? So one problem we have in trying to start an emerging scholars program is that the way the course credits are structured at Harvard, you get 1 credit for your course, and this add-on is not significant enough to count as another course. We can't give them a full course credit for the 2 hours they're doing fun, hard problems in the evening. At the same time, it's hard to keep up the enthusiasm and the attendance when they're not getting anything directly. I mean, they're still coming most of the time, and they're still putting in the effort when they come because they are getting the math out of it. But with the really busy students in the evening meetings and not being able to give credit, I think that's part of the reason why we had the attendance problems. I was also a little worried that, so I was running this, and it was my first semester at Harvard, and I was worried maybe I just wasn't charismatic enough as a teacher, and so I recruited someone else to run the second semester. And in the second semester, we had a really fantastic postdoc running the sessions in the evening. We had the same undergrad course assistant working with the students for some continuity, and the 3 of us were working on the worksheets that the students were doing together. And that actually was even worse. So it wasn't, it wasn't me. We haven't really figured out what the problem was. So if you guys have any suggestions, I'd love to hear them. On the other hand, the other program that I've worked with is our Calc 1 and in pre-calculus in 2 semesters course. So it's the lowest level math course that we offer. We dive right into calculus, but then sometimes we slow down and we do pre-calculus topics as we need them. And this class meets every day. We try to sell it to the students like a language course, but the format is different on alternating days. So they meet 3 times a week in a more traditional math class. It's not exactly a lecture. I think it might be what they call IBL at Michigan. It's problem-based, but it's very guided, and sometimes they're working on the problems themselves, and sometimes they're working on the problems in groups. But that's with with a preceptor or a postdoc or a graduate student. And then for the other 2 days of the week, we're really fortunate in Math M. We have very small class sizes. We have the 3 days a week courses are capped, just in Math M, are capped at 15 students. 2 days a week, they're in their workshops, which are IBL workshops. They're working not individually, they're working in groups at the board on problems with some guidance, but as little as we can give them to get them to the point of the lesson. And those are actually between 6 and 9 students, so they're very small. They're getting a lot of attention, and those are run by undergrad assistants who we spend a lot of time training. We pick the best of our CAs to let them have these classes that they're in charge of, which is a great experience for them. It's a great thing to put on their grad school applications, and it's really fun to work with them. And this seems to be working fantastically. This is a great class. We don't have a Math M without workshops to compare scores to, but it's really amazing the strides we see in these students, and I think that the workshops are a big part of it. One of the things, I think that having there is some resistance to the 5 days a week, but I do think that having the course in the 2 different formats gets over some of the resistance you get to these students who don't want to do this completely IBL thing, especially coming straight out of high school. Why aren't you teaching me this stuff? To have both formats is working extremely well in this class. And so what we'd like to learn is how can we don't want to make the Calc 1 students have to do 5 days a week, but we want to sort of give them this option like we were doing in the Emerging Scholars Program. And so we're trying to figure out how to learn from the success of the Math M program to restart this Emerging Scholars Program. So I'd love to hear any suggestions. And that's all.
Thank you very much. I'm going to ask people from the University of Texas, and then we'll have questions. So Mike Starberg, and I don't know whether you have Mark coming up or not. Okay, yes.
I'm Mike Starbird, and this is Mark Daniels. Are you Mark Daniels?
Yes, I am Mark Daniels.
So, when I think about accomplishments and things to learn, I really think about individual students whose attitudes about learning and living have changed because of the experience in these classes. Of course, that's what it's all about. When you see an individual who comes in thinking their job in education and in their life is to sit there and listen and try to remember part of it, and they end up at the end of the semester or partway through thinking their job is to actually produce ideas and to think for themselves. It's just a revolution in their attitude that they're going to take with them the rest of their lives. So that's the exciting part, and that's the part all of us are here for. So having said what we're really after, we'll now talk about things like the programs and the strategies for trying to have this effect occur for as many students as we can hope to reach. And so many things have been happening at the University of Texas, and we want to tell about some of them. Some of them are related to the mathematics department itself, and many of them are related to things outside the department. And so those are ones that we're going to particularly emphasize today. So Mark, do you want to start?
I'll start with inquiry flags. At the University of Texas at Austin, in addition to, for students to get their degree, in addition to fulfilling the course requirements, students have to pick up flags. There are writing flags, quantitative reasoning flags, independent inquiry flags. What's another one?
Things associated with international studies.
International studies.
Ethics.
Okay. So we have these various flags. We're going to do this as a discussion. Yeah. We have these various flags that students have to pick up, and for them to get these flags, there's some paperwork and some proposals that have to go in to attach flags to courses. And this year, this has been a 3-year process. So one thing we've learned about in the center is persistence is huge. So this year, we were able to get 19 courses with flags on them and associated with 10 different faculty teaching them. So that's huge. That gives students an incentive to take IBL courses, and we're just very happy that this has finally come through.
Well, and I should say about this, the whole existence of the inquiry flag came about from a committee that was created it was the Commission of 125 committee that was created where people looked at the undergraduate program.
Weren't you on that committee, Mike?
I was on that committee. Surprisingly enough, I was on the committee. It was chaired by the then dean of the law school, who's now the president of the university, Bill Powers. And one of the things that came out of that committee was to have such things as inquiry should be part of the experience of every student, and then how could this be instantiated in the university? Well, it came out having this flag concept of associating that experience with a particular course, and then the courses apply for this designation through the university, and then every student has to have, or I would say gets to have, this experience in these various themes. So.
All right, so we finally got that through, and Mike helped form the criteria for all these flags. I was specifically on the inquiry flag committee, and as I said, it's been a long 3 years to get something done about that, and we're very pleased. The next thing we wanted to mention was flipped classes. And we've flipped all our N and S. We have an alphabet soup of calculus sections, but we flipped all our N and S sections of calculus, and that's 12 sections a semester. Next year we'll start on 408 C and D, so the C and D sections will be flipped, and that's another 8 or 9 course sections with all the recitation and discussion sections associated with them. And the flipping has to do with putting just the general lecture materials online, having students look at those things before they come to class. As an incentive, they have to take a small quiz on each module because they're all human and they don't always feel they have to look at things before class. But it seems to be working. We've done this for a little over a year now, and students are coming to class fairly well prepared, and the classes now are more run in a problem-based, inquiry-based way. And we're finding that not only are the students enjoying it, it hasn't been going long enough, but there's a lot of evidence to show test-wise and grade-wise that they're doing better. And along those lines, we've incorporated learning assistants. That's what we call our undergraduate helpers, as Ralph mentioned, as Harvard mentioned. We have them in the class. Next year we'll have 50 undergraduate learning assistants associated with our calculus courses. And we're training them, we're training the TAs, and we're training the faculty on these courses. And one of the things we've learned is there are a few old faculty that are interested in these new ways. We've had Lorenzo Sadoun, Mark Maxwell, faculty that didn't normally teach in an IBL method in any way are very excited about such things. And maybe Mike wants to talk about that a little more.
Well, first of all, our calculus classes, I'd say, unfortunately, are taught in groups of 120 at a time.
Yeah.
So when we're talking about how to incorporate some of this inquiry strategy into such huge groups, this idea of flipping the class, meaning that during the actual sessions of the 120 class, questions are posed, challenge questions are posed, and then the students work in groups of 3 or 4, and the faculty members and the undergraduate assistants and the graduate assistants walk around these groups and are finding out how people are getting, where they're getting stuck and how they're doing, and then presentations are made interspersed with that. The thing that was interesting about this was that there was the decision that every one of the sections of one of these particular categories of calculus, all of them were done. So this was like a group of 9, I think there were 9 faculty members, and they all had to agree to use this method of instruction. And many of them had never used any inquiry kind of instruction. And so they met once a week on Friday morning at 11 o'clock. All these faculty members would come together and discuss their experience of that week. And they would also work collaboratively to create the challenge questions that they were going to use in the classes. And there's a huge need for constructing the appropriate challenge questions to make those class hours the most productive possible. So this is one of the big efforts that's needed to make this thing really successful, but we're working on it. So anyway, but it's very exciting because this was the first time that I know of where a whole group of faculty were, so to speak, required to use a particular method of instruction that they used inquiry. And it worked quite successfully, although there were, I think, maybe 2 people in that group didn't like it, and they really resisted even to the end. But most of them actually were won over.
Mm-hmm. It's very nice. And one reason we did this flipping was it came out of a reform effort that our current chair, Alan Reed, suggested. He formed a committee. Weren't you on that committee, Mike? Yes. To look at our undergraduate instruction in general and offer suggestions, and not just, these grand suggestions that will never get done, but realistic suggestions with a timeline of how to implement them. Instead of trying to do 10 different new ideas at once, the thought was, okay, we'll start with calculus, we'll work on that, we'll move on to other things.
Yeah, and we should also say that this, the flipped class idea is being supported by a university course transformation project, which is giving financial support and also has supported other work in other fields, biology, chemistry, and statistics, where they have used these inquiry kinds of methods in those courses as well. And that comes from our college-wide discovery learning project, which has monthly lunches and faculty workshops. And Mark chairs that committee.
Yes.
And so, or is the director of discovery learning. And you might want to talk about like the workshops that we offer to the whole college.
Yes, a few years ago we started, well, every year for about the last 10 years, we've had a new faculty workshop. And we try to train, in the past we've had speakers come in. And the speakers have talked 3 or 4 times over the day, and we've had some training ideas. But about 3 years ago, there was some discussion. Mike was in on that. Michael Martyr, a physicist, was in on that. And because it's for mathematics and science faculty, we said, having a new faculty workshop shouldn't be just listening to people talk. So we revamped about 3 years ago, and now we have just full-on training. We show videos, for example. We have some videos of Mike teaching IBL, and we take some grad students and the new faculty, and we split. Mathematics goes to one section, science goes to the other, and all these inquiry-based ideas and various levels of inquiry are discussed. So we're really trying to expose new faculty and really spread this word. And it's a 2-day workshop that we do in March now every year. unofficially, I think you should mention that, you know, Lorenzo Sadoun went around.
Oh, yeah.
Yeah, so go ahead. Go ahead.
Okay, well, so Lorenzo Sadoun was one of these faculty members who was, okay, so I should go back a little bit, which is, so I chaired a committee to look at the undergraduate program in mathematics, and we met every week for a year. And this had never been done in my entire 38 years at the University of Texas, looking at the undergraduate program. So that was interesting in itself. And one of the outcomes was that we recommended that there be somebody who was the chair of the Undergraduate Studies Committee who was actually, had incentives to actually work on it and do stuff. And Lorenzo Sadoun accepted the position of taking on that role. Part of that was calculus reform and trying to get more inquiry into calculus, and so he volunteered to be one of the teachers among these 9 who were required to teach their courses in this more inquiry-based way. And he was one of the ones who was a diehard lecturer guy, you know. And it turned out that he was completely won over. He just realized that this was a better way to instruct students. And I've heard him now talk in subsequent, he was actually at this meeting. I was looking around to see if he was here. But he was just won over and said, this is the way to teach. I will refuse to teach my classes just in the standard lecture style anymore. And which was, you know, rather interesting for those of us who had heard him speak previously. But one thing he did in his role as the chair of the Undergraduate Studies Committee is this semester he attended every class at the University of Texas, every undergraduate class, which like 120 classes, and he attended every one of them for like 15 minutes, and then he'd go to the next one. And he wrote a little report, and in the report he said he noticed that, first of all, one specific thing he measured was attendance. And he said the attendance at the sections of like calculus and ordinary classes, he'd say the average attendance was 55% for the ones that were lecture. For those who had this flipped version, it was something like 89%. It was incredible. Just being there was a huge difference. And he looked at many of the sections that were not designated as IBL, but have infused IBL methods. He said they were using IBL methods in our discrete mathematics class, where there were several sections. He said the ones that had using IBL methods, the attendance was in the 80 to 90%, and those not were in the 65%. You know, so, and he also referred to the attentiveness and you know, he said when the professor turns to the board and starts to lecture, he could just see the eyes droop down, and then when they were asked to do something, they became alive. And so it was interesting that he was just making these observations and not, you know, I mean, he wasn't drawing conclusions from them except to make the observation. So I thought it was a very interesting, you know, set of observations. Sandra, you sort of follows from some of your work. But anyway, that was interesting.
Mm-hmm. Are we running out of time?
Okay.
Oh, but we have 6 more? No, anyway.
We have
All
7
right,
more.
7 more. Well,
Okay, what are you going to do?
Well, one thing, Mike started with talking about what was going on here in the student experience. So I'll end my part. Mike can say something else because he doesn't care about time as much as I do. Tom Ingram caught me this morning, and he said, you know, I used your name in vain. He said, we always talk about at these conferences, you know, what the students say, and the students like it, and students this, and Tom volunteered me to create a panel of students for next year so we could actually have the students get up and speak about their experience. And I think that would be quite compelling. So that's one thing I'm going to work on. And I've learned that if you talk to the students, one thing we've learned is the students are your best, I think your best, you know, the best people to promote IBL because listening to them, not all of them like it, but a large majority really think it's a good way to go.
Yeah. Well, yeah, so maybe we should, okay, so I'm going to just go through this list very quickly.
All right.
So we're doing a UT system workshop to try to spread it to the University of Texas system. It's incorporated, we're using IBL methods in signature courses, which are freshman introduction to college thinking kind of a program. You Teach is a program that is involved in preparing science and mathematics teachers, and that's being replicated nationally, as many of you know. The MAA textbook series, I did want to say this. Brian Katz and I just wrote a book called Distilling Ideas, An Introduction to Mathematics Through Inquiry, which is it and our previous book, not his and mine, but Number Theory Through Inquiry, are published by the MAA textbook series, and they're starting a sub-series that we worked on with them to try to have materials in inquiry-based learning materials published by the Mathematics Association of America. So we encourage all of you to work on contributions to that MAA series. And that would be really great. The concept is to have a whole bunch of materials. We have this wonderful Jibble site, which has the Journal of Inquiry-Based Learning that has materials, and now the MAA is producing materials, and David Clark's thing is in the AMS series. So it's really great to have all of these venues promoting inquiry-based learning as part of the effective strategies. And the production of materials is one of the ways to make this a practical method for faculty members across the country to use it. And okay, we'll stop.
All right, I want to say just a few very broad things about the work we've been doing. If you have interest in the particular study, you can contact me. So I want to talk about what we've learned from our large mixed method study of IBL as implemented at the 4 centers. One thing I want to point out is that the centers didn't agree up front on what that meant, what IBL meant. So we have a variety of species of IBL, some of which are more closely related than others, some of which may look superficially the same, but in fact are rather different underneath biologically. So our approach has not been to judge that or to only study the yellow warblers, but rather to study all of it and then just know which ones are the bats. So I just want to point out that the results we have are based on very, very diverse samples with a wide range. And as an educational researcher, what I'll say about that is that makes it harder to tease out a signal. And the fact that we've gotten as robust results as we have is really pretty darn amazing. So very good news. All right, so what have we learned? Let's start with student learning. Just broadly speaking, over multiple kinds of measures, IBL students report higher learning gains, whether that's on surveys or in interviews. They're very articulate, as Mark and Mike pointed out, about talking about what they've learned. That includes cognitive things, right? The intellectual growth as mathematicians and understanding and applying ideas, being able to teach ideas, affective, the inside things, the confidence, the attitude, the persistence, and the collaboration with others. Their grades are as good or better than those of non-IBL students from the same courses. I'll say more about that in a minute. And their attitudes and beliefs are more supportive of learning in general, again, compared to non-IBL students. So I'm going to use a metaphor that Stan Yoshinobu uses when talking about this work, which is all the arrows point the same way, right? Which is really very good. We actually have really no negative results about this. We have some neutral results. And those are also good news because they tell us no harm is done in areas that we might care about. So that's the broad picture. A couple of very interesting results that I have been enjoying talking about and have been writing about lately. We have lots of publications that are under review right now. One of those is that IBL courses level the playing field for women. What we see when we look at the non-IBL courses, the comparative courses, the sections of the same courses that are taught by IBL, there's a gender gap. Women report less satisfaction, lower mastery of the concepts. Their attitudes are more negative, their confidence is lower, and these are significantly different results, statistically significant results, pretty much across the board in almost all the measures. But that gap is erased almost completely oops, I got a typo there, in the IBL classrooms, right? And so what we're doing here is not fixing women, we're fixing a problematic course, right? The lecture-based course is problematic for women, they tell us about it, and we can fix that problem by using IBL. So that's good news, right? When we're concerned about the the fair representation and inclusion of women's talents in mathematics and science. Just to sort of, this is kind of a summary chart talking about the size of those effects. What you see is that in the top row, these are effect sizes measured in standard deviations. So taking an IBL course has a positive effect of about 1/4 of a standard deviation, regardless of student gender. Being male has a positive effect, which is smaller on cognitive and affective gains, right? So that's the point about there's a gender gap. When you take those two together, you get a large combined effect that being male in a traditional non-IBL course is almost half a standard deviation higher self-reported learning gains. They're self-perceptions. And the fact the effect size goes away, right? It's down to within the noise when we look at IBL courses. In other words, gender is no longer an advantage. That's what I mean by erases the difference, right? We're not advantaging women, we're taking away the disadvantage. So this is just a nice result that is in one of the papers we've got under review right now. Okay, another point I want to mention is just another result that I'm excited about these days. This is from our grades and academic records study. And this image here of the Ile-de-France and the Seine River here is to remind me to say that this is a study of looking at students who have gone on either channel, right, the IBL or non-IBL channel around the island, and we're looking at their grades after they come back together, after the river has rejoined, and they're all in the same courses again, right? So we're not looking at their grades in the IBL courses themselves, because we know you grade differently and think about those courses differently. We're saying now that they're back mixed together, how do they do? And so what we find is that the grades of those students are the same or better in subsequent courses, the courses they take later on. So that's a really important result. It sounds like a non-result, but it's actually really important, because one of the main criticisms that we get of these kinds of methods is that they go slower and you don't cover as much. And what this tells us is the students don't miss what you didn't cover, right? Or they got something that was equally valuable to them. So maybe they didn't know about something you didn't do in class, but they got something else that made up the gap. We don't know why, right? All we can do is look at their grades. We don't know why those grades are the same. But it's really important to know that the coverage myth is in fact a myth, okay? So that's a really good result that you should use when you're talking to colleagues. Another result from the grade study that I like very much, and this is the only actual data slide I'll show you, is that if you sort students into high, medium, and low grades on their incoming grades, the grades they have coming into the IBL or comparative course, what you see is that in those later courses, the downstream courses after everybody's back in the same sections, pretty much everybody's grades go down a little bit. The courses get harder, right? So even your very top students coming in, you know, they go from A's to A minuses, okay? But that one group whose bars you can see sticking up positively all across the different kinds of courses that we looked at are the low achievers who took an IBL course, right? So for those students, their grades improve, and what we're plotting here is the change in grades. And so what you see is that the change in grades is, you know, 0.3 or more grade point units of improvement in their later grades. Even though the courses are getting harder and everybody else is doing a little less well, these guys are doing better. And that's different from their peers, the initially lower achieving students in the non-IBL courses who took the lecture course, and it's different than their higher achieving peers. So this is a really interesting result. And what we think it means is that students who experience an IBL course take something with them that is valuable to them later on, perhaps an approach to learning mathematics, an approach to studying hard. Maybe these are students whose grades were less good at coming in because they didn't know how to work hard in a lecture course. They sat, they listened, they thought they understood it. When it came to the test, they couldn't reproduce it. Something about the IBL course may be helping them to learn how to dig in and really chew on the material, and they're doing that later on. Again, we don't know the whys about this. It would be very interesting to study that, but we think it's a really interesting result that you should know about. Okay, what have we learned about instruction? I think two important things. One is that we find a positive signal of IBL even in courses that are not fully IBL-ified yet. Okay? So, and even in courses taught by new instructors who aren't perhaps very good at it yet. So we're seeing positive effects just by changing the instruction to include these student-centered, exploratory, and investigative kinds of activities, that's a good thing, right? So it means you don't have to be perfect at it. Just do it, right? The second thing is that if you do, or as you do refine your practice, the things to focus on as you think about how to make this better, how to get better at IBL teaching, are really the two key learning approaches. And we can group a lot of things that students tell us about how they learn into two big categories. One is individual engagement with meaningful mathematical tasks, right? Doing important math that matters, not plug and chug, practice, spew out the answer kind of stuff, but meaningful things that make them think. And then the other important piece is collaborative processing, right? Talking about the math with other students, comparing their results, comparing their solutions, realizing other people do it different ways, refining their results. And that can be in class discussion, somebody presents a proof and then you talk about it. It can be in small group work. In some cases it happens outside class. But we think those two things are both important. You have something important to do, you've worked on it yourself, you have something to say, and then you talk about it with others and make it better in that process. Okay, and the last thing I want to mention is what have we learned about institutional change? Here are two examples of change movements from the early 20th century. One is the women's suffrage movement. That one stuck. I do get to vote. The other one is the prohibition movement. Fortunately, that one didn't stink. I could have a beer with my dinner last night. And I want to mention those as two examples of change where we can talk about what stuck, what sustained, and how did it happen. And so I think from the centers, we've learned some things, and you've heard them this morning, about how to change things. I think one thing that's really important is finding ways to inform and engage your colleagues. Even the ones you know will never do this and will never take it up, it's turned out, as Mike and Mark just showed, and as others have talked about earlier, it matters that they know what you're up to, and that you don't treat them like hostile territory, but just keep them informed and up to date. That turns out to be important. I think the centers have given us several interesting models for building in really explicit support for new instructors through mentoring and team teaching kinds of models, and more informal, collaborative, collegial things, using IBL as a focal point for building that community of practice, right? If you start talking about IBL, it turns out you just talk more about teaching, and that's a good thing. The early career instructors have been just crucial at the centers. They are the people who are the most, they are coming in skeptical or interested or completely open-minded. They come out feeling quite committed to this approach. They see it as a flexible toolkit. They talk about things, well, I don't do IBL in that course, but it's IBL-like because. And so that's really powerful, right? It gives them a whole set of ways to adapt this. They don't see it as an approach. They see it as a toolkit of approaches. And they take it with them when they move on. In our interviews with grad students and postdocs, more than 85% of them said they would do this again. All right, that's pretty good, right? They had an experience, it was new, and they're taking it with them. They're also really important people in this community of practice. They talk to each other. And I think one thing I heard this morning that I just added to my slide here a minute ago was that when we talk about sustainability, keeping things going, that may start to look more like leakage or contamination, right? It may not be sustaining the same thing over and over again, but rather spreading it around, and the flags and the things that Ralph was talking about things leaking into other departments and leaking into other courses. That's what sustainability might look like. It might not look like doing the same thing forever. And so I think those are interesting developments at the centers. And so what I want to posit here is that although we tend to talk about courses and materials and resources, those may be ways to get people involved, but really what you're changing is people. You're changing people's minds and hearts, and they come out of this thinking there just isn't any other way I could do this. And that means you've really changed something, right? And you've gone on. So that's a way to think about it. How do we help people get involved? But really, we're changing people in the end. All right, so just to sum up, we have good evidence from a messy system, right, from a diverse system, that IBL methods do benefit students. We've got a couple of particularly interesting examples of particular groups that benefit more, not to the detriment of others, but just helping to level the playing field and make opportunities for learning equal. We can show that these outcomes are linked to the use of active learning approaches that you're using in class. And we're starting to see some interesting examples, I think, of the spread and sustainability of IBL coming out of the centers as they problem solve and figure out how to keep this going and how to do it. Our work, again, we have several papers in review. I can't share those yet because I need to get back to not mess up the peer review system. It's pokey in education, and I know you're impatient for it, but this is the website where we'll post things when they become available. So keep an eye out there for our work as it comes out. And feel free to get in touch if you have questions.
Thank you very much, Sandra. We have time for one or two questions. Yes.
Do you have data on students who drop courses, drop IBL courses versus non-IBL courses?
Students who drop?
Drop.
We, in the courses, we looked at that. We found that in the particular courses that the centers were offering, there wasn't much of a drop rate, so we can't see a difference. We also looked at major changes. You know, did this pull anybody into the math major or kick them out? We don't see a difference, but we don't think it's a particularly good study setting for that.
Sandra, have you had a chance to look at whether the IBL experience in mathematics impacts student performance then or later in non-mathematics courses?
We didn't examine that in our academic records study. Again, the courses that were suitable for that study were fairly advanced math courses, and they were pretty committed math students. So I don't know where we would have looked, I guess. The setting for that kind of study would be the freshman experiences, and I was glad Ralph pointed out how important those are. We do see some evidence that these experiences are most powerful early on, and that would be the place you'd want to look, but we did not.
I was wondering, have you ever been challenged on the method of evaluation of IBL students versus non-IBL? For example, say students coming out of a calculus course, give them a test, and then one class and the same test in another and compare. It seems to me that might be a better, more instantaneous way if you were using these results to, say, raise funds for IBL financing.
We would love to do such a study. This setting, we didn't have enough courses in common across the centers to do that. And we also, when we approached instructors about giving a common assessment at the end of the course, nobody took us up on it. We worked pretty hard. We couldn't really twist arms, but we could offer bribes, and nobody took us up on it.
Somebody's afraid of losing. I don't know.
I think so. It's a concern, right? You don't want to put faculty into a horse race, but we would love to have a site which would be open to doing that with multiple instructors. We would need a pretty good sized site to get to make it worth doing. And we'd have to have some agreement on what that common assessment looked like. And we'd love to do that study, but this was not the case we could do it. But every study you learn something new about the next one you'd want to design. So don't lose that thought.
Other questions?
Yeah.
Just wanted to say that at University of Michigan, we did have a calculus inventory test a couple of years ago. We have IBL calculus, and we did amazingly better than the other programs that were in this calculus inventory test. And those results are well known.
We did try a test result, and because we couldn't get instructors to take class time to give it in class, it was a proof, analysis of proof test, which we thought would be a fairly general skill that lots of IBL courses would value. So we ended up giving it to volunteers, and we paid them $25 to come take a test. And if you think about who wants to come take a test, even for $25, it's good students. So everybody did great on the test, and we couldn't see much difference. We really would like C students to take that test, but $25 isn't enough for them. And the IRB won't approve much more as your incentive. So we tried it, but it was not a good design, and we know that. And we'd like another crack at it with folks who could persuade everyone to take part.
To a large extent, I would think that what happens to students after they take IBL courses would be actually more important than what they learned or how they performed at the very end of the course itself, which of course is what Sandra's study did measure, but of course in a very limited way. Other questions?
Yeah.
We're running out of time.
This is a general question about the centers. I wonder if any of the centers have created any course materials that we could publish in the Journal of Inquiry-Based Learning in Mathematics. So these are course materials for entire course.
Well, they've certainly developed a whole range of courses of one kind or another.
So maybe...
I think that's a great idea, David. I think they should send all their stuff to you.
Okay, we'd like to have it.
Any other questions?
Have you formulated any kind of credible hypothesis on the basis of your studies as to why there is this gender gap? Why is it that the women seem to benefit so much more in these studies than the men?
Well, I think the explanation lies in what's wrong with the traditional course, less than in what's right with IBL. I mean, that's obviously a factor, right? But, and to be honest, we started this study assuming that was well known and understood. We thought that literature would tell us all about it, so we didn't spend a lot of time probing gender issues in the traditional course. And now I wish we had, because I would like to know.
I don't think you expected that outcome.
No, we didn't expect that outcome. And in fact, when we asked instructors about did they see differences in student outcomes, very few mentioned gender. So it surprised us a little bit. I would say that I think there's heavy cultural stereotypes about math and who's good at math. We know that there's a great study of children whose teachers have, whose grade school, elementary school teachers' attitudes about mathematics are affected if the teacher is female and communicates a negative attitude about mathematics. Girls' test scores in her class are worse than boys. Second grade, already second grade. I think that's devastating, but that tells us it starts really early, this message about who's good at math. So I think that's a factor, and it holds on even to high-achieving women who are taking these college math classes. It must be fairly easy, I think, to trigger those stereotypes and self-doubt. And there's a good body of psychological research that says even being reminded, you know, if there are stereotypes in the culture that boys are better at math, then being reminded of those, just as you go to take a math test, can drop your scores. There's interesting research that says if you ask students to fill out the demographic part of the SAT test before they take the test, the women do worse than if you ask them to just fill that out at the end of the test. In other words, just reminding them, you know, you're representing your gender here, and we all know women aren't as good at math. It's amazing to me that it's that powerful, but the research is really quite robust on this. So I think it has to do with that, but I don't know exactly what. I'd love to sit down in classes and observe a little more and see if I could detect that.
One more question. We're running out of time.
So this will be so super quick. I just wanted to reference your leakage comment, which I think is really great. This is sustainability might look a little bit like leakage, and I thought back to, because you know we're working with teachers who are teaching several subjects when we're working with K-6, and teachers, we've seen teachers change to a more IBL approach in their language arts and in their social studies. And one teacher said to me just a couple of weeks ago, she said, I really want to be an IBL parent.
Oh, nice.
And this is how I want to, when I have children, this is how I want to be. I want to be asking questions. I want to be listening to my child. I want to be, you know, you get the idea. So it's very pleasing to hear you say that, reference that today.
Boy, you're going to need to be an IBL parent if your second grader has a teacher who's communicating something different. So that's a good defense.
Yes. Well, thank you all very much for attending. One more. Sorry.
Okay, it's not a question, it's just a comment. So this is my first IBL conference, and I think that having this type of data is really, really important, because I am really a lecturer, and I've been trying IBL, and this allows me to, you know, be more confident in trying it. And so I'm just, you know, really grateful that you have this, because it seems like it's working, but, you know, my lowest common denominator instincts come back, and I need reasons to avoid them.
Thank you very much.
Thanks.